Good morning, friends. So I'm glad I'll be talking about how to deny yourself access to your production environment. If anyone wants to turn their video on, please do so. I got a grid view open, so you can wave a hand and I'll hopefully see if you have a question. If you wonder about anything, I have the WebEx chat and the Slack open. If I don't catch it, Gregor will and let me know. Um, I'll try to answer some questions as we go along if it's a natural question. If not, I'll try to save them for the end. So we're going to deny ourselves access to production. Well, first of all, why would you do that? Well, there's multiple reasons why you do not want access to production. First of all, it makes it much harder to screw up. You can type the wrong command in the wrong window, delete a resource you shouldn't have, and so on and so forth. I had one time where I was logged in as an admin and I didn't notice it, but as I was moving my mouse over Windows Explorer, I accidentally touched my button. What I did, I took a folder and dragged and dropped it into another folder. And in about 5 minutes, there was about 500 users that couldn't log in because their home directory could not be found. And when people start coming in having that weird error and their user directory is gone and you know you're the only one that was logged in as an admin that day, it's like, oh, dang. So it makes it harder to screw up. It also makes it harder for an unfaithful employee to steal production data or personal data or screw with data. Production data may contain personal identifiable information. It can contain critical business information, and you might be obligated, even under law, to keep this data safe and secure. So having these measures in place will make it easier to justify that actually we have our stuff under control. It also makes it harder for someone external to steal your data, because if your machine is compromised and your logged on account has access to production data, then whoever compromised your machine has compromised your entire production data. And you don't really want that either. So it's not enough. You don't want it to be enough to compromise your machine, but you also want them to have to struggle to get further in. And it creates this little barrier that you have to cross whenever you absolutely need access to production, helping you get into that mindset of I got to be careful here. Now I'm stepping on live wires here, so let's keep this nice and tight. Now, one important point. The object here is not to make it impossible to get raw access to production, but we want to make it explicit and we want to make it auditable, meaning that we can see who had access to production and when. And we don't want to make it accidental. That's the explicit part. Now, that out of the way, let's take a little bit look into history. So traditionally, our developer would never have access to production. They would build their little code and they would take the code, package it up, and throw it over a wall to someone else working in ops. The operations, they would take the code, they would follow whatever instructions came along, and they would install it, and we would hope that was okay. I once had a contract where they had a weird error that only appeared in production. So I was tasked to figure out what that was, and they hadn't really been generous with their logging, so I had to go into the code and try to figure out where this error was in the code, even because it wasn't obvious. So we'd go in and add some broad log statements, try to narrow it down. So I would take the code, make some changes, ship it to a developer in another country. They would take the code, they would package it, and they would ship it to another ops person in another country who would install it on the server. They would get some logs out of that, and they would ship those logs to me. And then I could go through the logs and see, oh, is this okay? And what happened here? And then the cycle would repeat. I would make more logs, more log points. Okay, it's in this area, and so on and so forth, and narrow it down. This wasn't very fluid. In addition, this developer here, he quit every day at 1600. That's when he went home. The ops guy did not. I was hired, like, take whatever overtime you want, just get this done. Nobody told the developer in the other country that he was supposed to work on this 24/7, but it didn't really work out that well. And almost every developer with like more than 10 years of experience, and often less, has a story like this. So eventually, culture like DevOps took hold. Developers and ops started working together as a single team. And also the self-service cloud arrived, making it super easy for someone to set up an environment. Before the cloud, before the self-service public cloud, very often, if you wanted to put your software on a server, there was weeks of waiting time. And you would never get access to that server. That was, okay, the server is ready for you, give us the code. Now, the self-service cloud makes it an orders of magnitude easier for developers to just stand up a complete environment, test, dev, production, everything. And in my experience, both of these things have radically increased the number of developers that has access to a production environment. So there's been a shift here. And let's be honest, most of us, at the time at least, were super happy to be able to push straight to production without talking to ops or security. Now, there's problems with this. One of the problems is that working with access to production makes you vulnerable. It's a higher risk of mistakes. It's a higher risk of theft. So you expose yourself much more when you have access to production. The consequences are bigger. So if you compromise a client machine, will equal a compromise of a production system, which is not particularly good. And also, the problem is blame. If you don't have access to production, then you can't be blamed for mistakes happening in production. So it's sort of like a preventive maintenance on your own part. So you figured out that, okay, maybe I shouldn't have access to production. How can I still get my job done in a relatively easy fashion? Well, we're going to discuss some solutions and some techniques that can be used to make things a little bit easier. So, and sometimes you actually need access to production. There's no other way around it. You have to go in and do stuff. And how can we do this in a secure and auditable fashion? So the first thing you want to do is that you want to set up a super user, also known as the emergency admin. The emergency admin, or your super user, is the ultimate failsafe. This is an account that you should set up as the owner of everything. Very often when you set up a public cloud solution, you become the owner of everything. So, and that's not ideal. So don't use your own account to set up services. Use your super user account to set up services and become the admin and the owner of these things. You want to be careful with the MFA, the multi-factor authentication. You should consider protecting it with an MFA, but it should be an MFA that is not tied to a particular person. For instance, if the MFA on the super user is your phone and you decide one day, I'm going to join the circus, your company is screwed because they can't log into the super user and you left with your other account that was also a super user. So you want to, there's hardware MFAs, hardware keys that you can use to protect the account, which can be stored at the company location. And sometimes you want to not have an MFA on that particular super user as well. Make sure that you can log in even if catastrophe has happened. Your office is decimated, your building is gone, your account manager left, and so on and so forth. The thing with the super user is not only should you use this in emergencies, and only emergencies. The goal is to never have to use this account, but it is the escape hatch for the company if something happens to whoever are able to get access. Now, this account should be audited like mad. You should set up logging for when this account is logged on, and you should set up alerting for when this account is logged on. When this account is logged on, you and someone else should always get an email notifying that someone logged into our super user account. And then you go, that's not supposed to happen, and you can do something about that. So now we set up that you're not the owner of anything anymore, but you can still assign permissions to yourself if you want to. But we can also assign permissions to other users. So that's the whole trick here, that we remove our permissions and we add permissions to some services. Now, what do we do as developers? Well, we create code. This code goes into production. Instead of doing that work ourselves or handing it to another person to do it, we can have the machines do it. We do that through a CI/CD environment. Continuous integration, continuous deployment. Continuous integration is the system that when you check your code into source control, for instance, GitHub, it will detect, oh, something went into source control. There's a new version. I'll take the code and I'll build it, which is the CI server, the continuous integration. Then it will pass that on to a deployment system. Now, we use the term continuous deployment, but it doesn't have to be continuous. It can be shipped over to a release system, and it can be a manual thing where you can say, okay, I want this version going to production. But what happens then is that this machine here takes your code and deploys it to production. It's no longer you that does it. And this machine can have an identity which has permissions in your production environment. So you can give that service, that which you use for deployment, access to your production environment and push the code to it. So now you don't have to have permissions to push the code anywhere. So that's your code. But what about your infrastructure? Setting up services, one of these, one of that, and so on and so forth. It is in the public cloud platforms, it is really easy to go in and just right click this, click the plus, new web server, new app, new container, new Kubernetes. Suddenly 4 clicks and you created your own private cloud in another cloud. And while that is super easy, we also like to have some control here. And scripting your deployments is a good thing, whether you're doing this or not, because then it's repeatable, it's documentable, you can tell what you had at which time and so forth. So we have the infrastructure as code is a concept where you describe your infrastructure in a machine readable language, sometimes a proper programming language, sometimes in a JSON or YAML file. You could use stuff like if you're in Azure, which most of my examples are going to be from, because Azure is the one I'm most familiar with. In Azure, you can use ARM templates, which is out of the box, built is one of the things supplied by Microsoft. We use Pulumi, Terraform, many people use, where you can describe your environment. I want one of these, connected to one of that, I want one of these, and so on and so forth. And you can also give this to your CI/CD system, which will deploy your environment or update your environment. If you remove a service from the infrastructure as code, which is checked into source control along with your normal source code, remove a resource, it gets removed, and so on. Add a resource, it gets added. Again, you're not doing it anymore. The CI/CD system is doing it. So, but then we have people making the code. So here's another way I can get malicious code, or if I'm have an unfaithful servant or an unfaithful employee in my company, they can create malicious code that will extract data and ship it somewhere else. So we need some kind of fail-safe, some kind of control here as well. And we usually do this by adding a step before the code goes into production, by having some kind of code review. And then we have to be two people to look at the code to approve it to go into the production environment. So that creates a situation where it's really hard for one person to add malicious code that puts the malicious code into the production environment. There's a check there that's saying, okay, you made some code, let's go over it. And normally code reviews, the main purpose of code reviews is not checking on someone else. It is to learn and broaden the knowledge and the collective knowledge of your code base. But it is also a fail-safe of what's going in here, what's going into our system. There's another pair of eyes on it, basically. And that also has to do with security, because sometimes developers make mistakes. And we say, oh, actually, that code is not, you're doing something here that is not secure. Let's fix that up. So make sure that you're not pushing the code in, the machines are doing it. Now, when the code is in the system, you often have systems talking to other systems. And in here, they have secrets. They have connection strings to databases. They have keys for external services, and so on and so forth. Passwords for databases is a huge problem. And it's really easy for people to set up a connection string, make a user in the SQL Server, get a password, put it in there. What you've done when you do that is often you've given every developer access to your database, because the username and password will often float around. It can often be available if someone goes in and looks at the settings and so on and so forth. So one of the tricks you can do to remove secrets is not rely on secret strings, but rely on identities instead. So you can have your app run as an identity. It runs as a user. In Azure, this can be, if you're on a local network, it can be a local user, it can be a domain user in your local network. In Azure, there's something called an MSI, a managed system identity, which is a user in Active Directory that can be assigned, created, managed by the system, Azure, and assigned to your application. And then you can have this MSI can get permissions to a database, for instance. That way, the connection string doesn't have any secrets. It doesn't have any usernames. It just says, access this database. And in your code, you say, access this database and add a token for my user, which is the logged on user for the app, which is the MSI, which you don't have control over. The MSI can be defined also as part of the infrastructure as code. So there's no secrets for the MSI. You just tell in Azure, for instance, when you set up a service, you said managed system, identity type managed system, and it's created. Sometimes there's secrets we can't get out of. Then you can use services like Key Vault. It's a particular Azure service named Key Vault, but the concept is the same and it exists in many forms, which is a sort of insecure environment where secrets are stored. And then you can take your MSI and you can grant it permissions to read secrets from the Key Vault. And the Key Vault contains secrets, and it can also contain certificates. Certificates are really good with the Key Vault because you can send stuff to the Key Vault, get it signed by the Key Vault, and then get it back signed by the certificate, which means the certificate never leaves the Key Vault. And the Key Vault, so what do? We just move secret from one place to another. Well, the Key Vault can be audited separately and can be given permissions separately. So you can have a stricter sense of permissions in the Key Vault than you do on your app. So again, your code doesn't have any secrets. Your web server doesn't have any secrets. But it says, when I need a secret, I'll go to the Key Vault and get it. Now then, by that time, the secret is in the code. If you write code that spits out the secret, yes, you do. But that's why we have code reviews. We don't do that. You can also have, when you need secrets, and you can create them yourself, you can have secrets auto-generated as part of the infrastructure as code. So it can say, create a Key Vault, create a web server, generate a random secret, put it into Key Vault, and your code points to that item. So that way, the secret is never created, never seen by human eyes. It is just created as the application is deployed. Now, in Azure, or in most cases, you have some kind of security boundary. In Azure, it's called a resource group. This is where you often want to set permissions. You also have another layer on top of that, which is the subscription. Normally, you'd set permissions on one of these levels, saying that I have access or I don't have access to this area. So you'll have either a separate subscription for your production environment, or you'll have a separate resource group for your environment. Then you have a bunch of stuff happening in here. And one of the things you should consider is shipping logs outside of your security boundary. That makes it, when you have troubles in production, getting access to the logs files is really, really helpful. It will cut down on your downtime significantly. You have to be careful, though. You have to make sure that you don't push out information that shouldn't be there. So you have to be careful what you're logging. This is particularly true with personal identifiable information, which you do not really want in your log files, because then you have a problem with the access and storage and retrieval and the retention of this personal identifiable information. So that opens up a whole can of worms that you do not really want. So do not write personal identifiable information to your log files. And here we can also grant individual access to the log files or the log system, saying that only these people are allowed to have access to the log files. So you can narrow the scope of who gets access, and they only get access to the log files, not the actual system or the actual data. Now, one other thing when we're creating applications that we often need to change is configuration. We want to set a setting, we want to add code, we want to turn stuff on and off. And we can use external services for that. There's two things. One is application configuration, the config settings of your application. They too can be stored outside your application. So there's services for, in Azure, there's something called application configuration, and there's lots of other services that will do the same thing, where your service will, when it starts up, will go to the config service, get whatever it needs, and take it back. Now, one of the things we often want to do is to change the configuration while the app is running. A common scenario is changing log levels. So we're having a problem in production, and we want to change the level of what information is logged. We no longer want to log only errors. We want to log warnings. We want to log information. We want to log debug messages. There's different levels here. Now, what you can do, what people often do, is that they go into production environment, they find the server, they find the configuration settings, change one setting, restart the web server, and off it goes. Moving your configuration outside the security boundary enables you to go here and change the setting, and application configuration and other services as well. They often have a client running on your app server that will periodically refresh the configuration data. So say you set it up to every 5 minutes, it will refresh the configuration data. You make a change, wait on average 2.5 minutes. It retrieves the new set and updates the configuration, and you're good to go. Now you're logging at a much higher level of detail, which is shipped off to an external service where you can see what's going on in your production environment without having access to the actual production environment. This can also happen with Key Vault secrets, where you can go and update Key Vault if you're running application configuration, it can be integrated with Key Vault, where on app config, you can have a setting that is actually a pointer to a Key Vault setting, where the service will not get the Key Vault setting from app config. It will say, it will just get a pointer, and then it will go to Key Vault and collect it. So these things can work in harmony. So now we have your system is running. You get your code, you write your code, you have it reviewed by someone else, so everyone knows what's going in. We share knowledge of what's happening. We also have a checkpoint there saying that no bad code is going into production environment. The code is deployed. If there's infrastructure code, then resources or sources are created or torn down. The code is deployed, the code is upgraded, and it starts and it runs. We don't have any secrets floating around. All permissions are by identity. So the application has access to the database, for instance, or has access to Key Vault, or has access to application configuration. Either of these things, all these remove the need of passwords and strings and connection strings. If we're talking between machines, we can use the same concept of the application that one machine runs under can get access to the application on another machine based on their identities. And we have moved configuration out, so we don't need access to production to change those things. And we have moved secrets out, the ones we need, so we don't need access to production to do anything with those things. And then sometimes you really need access. I talked about the security boundaries, resource groups, and subscriptions. Other systems, other clouds have similar concept, just named differently, but there are security boundaries. What we want is a way to get access to those security boundaries in a auditable, explicit fashion. It is not okay just to add yourself as an owner or be an owner and I'm not going to go in, I'm not going to use it, whatever. Azure has a solution for this called Privileged Identity Management, PIM. Privileged Identity Management is a whole sort of suite of things, but the ones that were particularly interesting for us is just-in-time assignment of roles. So in Azure, there's a bunch of roles, and this extends to Office 365, that whole thing as well. So there's a bunch of roles that are allowed to do specific things. For instance, on a resource group, there's a role called contributor. A contributor can go into resource group and do almost anything without that doesn't involve setting permissions, but you can add stuff, remove stuff, see what's going on, and so forth. The thing with you do with privileged identity management is that in advance, you set up the roles you want. You can make your own custom roles as well, saying that this role should have these kinds of permission. You combine some permissions and so forth. If you want to make it more granular. But let's say the role of contributor for a resource group. Now you add in advance saying that, okay, who is eligible to have this role? Who can I add? Who can ask to get this role? Because that's what you do in privileged identity management. You can go in and say, I would like to be a contributor to this particular resource group in Azure. Or I would like to be a contributor to this particular subscription in Azure. But we have to specify in advance who is allowed to ask that question. So we set up eligibility. So we're saying this role can be asked, and we can set a whole bunch of things here, saying that, okay, how long does the eligibility last? So you can say we can assign the eligibility permission for maybe a year, and then after a year, it has to be reassigned. This is to make sure that you don't have any trailing eligibility running around. Then I can request access. So my user can request assignment. I can request to be assigned this particular role. Now, depending on how I set up the eligibility, I can request it for a period of time. I request it with a start date and end date, and saying I would like to have this role from now and 2 hours. Again, depending on how I set up the role, I can do various requirements. I can, for instance, require that you have to re-authenticate with MFA, multi-factor authentication, saying that if you want to be assigned a role, you need to prove again that you are who you are with your MFA, which in Azure is usually the app on your phone for your account. Again, you can also require approval, saying that if someone wants to be assigned this role, that has to be approved of someone in this particular group. So that way you can say you have a checkpoint again saying that nobody can get access willy-nilly. There has to be some kind of process there saying, oh, well, actually, it has to be good. And they also can be forced to write a justification. And this is all self-service. They can go into a web page, they'll click, I would like to have this role, so-and-so, click here, justify, send. You can also not require MFA. You can also not require approval, saying, okay, we trust our people. These are good people. You don't have to be approved of access, but you can make sure it's an explicit action. So whenever you want to go into production, you go in, I want this role, and you're granted that role automatically. It takes about 30 seconds where it assigns the role, waits a little bit, and then refreshes your browser, and you have that role. You are now the owner of that particular resource group or that particular subscription, or the contributor. What this does, it creates an audit log. We can see who was given access, when they were given access, what justification they had for that access. And we know that when you're given that permission is removed automatically after a set time, or if I wanted removed earlier, I can go in and just unassign my assignment. I can say I'm done. I can deactivate it. I don't no longer need access to this. That's the basics of the privileged identity management tool. So then we have our code, which is reviewed. We have our infra, which is also reviewed. Goes through a deployment system into some kind of security boundary, for instance, a resource group, onto our machines. Now, try stuff that is not not sensitive. You can ship that out, log files. You can ask for things from outside your subscription or outside your resource group, for instance, config, or some things that are inside, secrets. If you want access, your user can have roles. Now, depending on your situation, you might sometimes have people permanently assigned read rights to your subscription so they can go in and they can see what's going on. Just because they have read access to a subscription doesn't mean that they have read access to your data. That depends on how your system is set up. So you can have users with normally having a reader role, and sometimes not at all. It's like you have no idea what's in production. Having users with a reader role, if that is okay with your data, is makes it things a lot easier when you're trying to troubleshoot, because then you can go in and you can watch logs and stuff like that. But it also heightens the risk a little bit of people seeing stuff they shouldn't be seeing, especially if you have secrets in configurations, because they are often plain text on the app, which is a reason why we move them out of the app and into secret stores like Key Vault here, which can have a separate set of permissions where they do not have access to read the different secrets. And we can use PIM to upgrade our roles to will give us, for instance, the contributor permission. Now, it's important now to figure out, why do I need access to production? In our cases, a lot of the reasons why we have needed access to production was because the data in production didn't make sense. Now, I work at a small law tech startup called Justify, and we have a lot of really personal data. People put in information to generate their testaments, will. They have cohabitation contracts, and now we're doing living wills, and there's a lot of really personal and sensitive information, and information that is just basic personal. It's when people write their wills, they can add messages to their loved ones from behind, and that's not really any information that we should be reading at all. There's no technical reason why we should read that information. So what we've done is that we made it easier and more privacy friendly to do some of the things that we need to do, because sometimes we'll get bugs in production that has to do with the way the data is shaped. The information the user put in makes another step break. So we have an admin system that can read, a little bit simplified, but it can read some data. Now, our lawyers have access to the admin system because they need that to do their jobs, and they're able to see most of this data. And some of it is hidden from even from them, because no human in our company needs to see that information. But they also have oh, now we're on rainbow colors. We also have a function to copy the technical part of the state of someone's will, and then use that in for troubleshooting. So we can see a version where all the sensitive data is removed and all the personal data is not in the document, and we can ship that off to a developer and can see what's going on here. And this is a manual process, but it's done through a tool that, again, we audit. So data access here is logged. So we can see who went into this customer, who viewed that customer data, and who took some data out of it, and what was taken out. We don't log what was taken out, but we in all the data, but we log what happened to it. So we can build these tools that will grant us access to things we often need without having to open all the doors and letting a developer in straight to the database and go through everything, because then it heightens the risk, right? If you let someone into the database, suddenly they're writing database commands in the wrong window, and they've deleted your entire production database. We also have some other cases where we have a more technical need. We get some requests for related to subscriptions and stuff like that, where we haven't really made a good business interface for, but we'll sometimes make, let's call it a tech admin pages, where we have some tasks that are specifically technical support, where we can, like, yeah, you have to know what you're doing in order to understand what's coming out, but the tool prevents us from doing something really bad. These are tasks that they're not big enough, and we don't want to invest enough to make a nice, fancy interface for it for our lawyers, but we can make it quick and dirty. Doesn't look good at all, but it gives us the exact information we need and nothing more for our technical people. So our developers can go in and say, okay, I need to look at what subscription type this person has, and we can see that here. And okay, there it goes. Yeah, okay, great. We need to some kind of process that we have to do. That is a technical thing. It's not a really a business kind of thing. It's not for our lawyers. Then we make our own process with that and make sure that we can do it safely, securely, and auditable. Again, back to the original point, the point here is not to make sure that you can never do anything in production. The point is to make it explicit, make it safer, and make it auditable so we can see what happened. So we have, in our case, all customer reading of customer data is logged. So we can go back and see who accessed the data and when the day was it accessed. Now, these are sort of break the glass tools because we're opening a little doorway in. But again, the developer making that code into that tool is also audited in a review. So a little bit about the practical processes of how we do it. So we have coders make code, we push it to a GitHub feature branch. In order to merge the branch into master or the trunk of the application, there's a code review, which requires approval. Now, we have some form of trust always, and the code reviews are logged. In situations where there is less trust, you can use, instead of GitHub, you can use stuff like Azure repos, where you can actually set permissions on the branches, and you can make it much clearer who has access or not. But we can also not be an admin on GitHub and not be able to force merge something in without approval. So there's ways of setting up. We haven't done that, but you can make it stricter if you want. Code that goes into master goes into CI, CD, and gets deployed, in our case, into Azure. We also not only have application code, we use Pulumi scripts, which is infrastructure as code, which again goes into the CI/CD and is used to set up the environment. So that will set up whatever web roles, whatever storage, whatever key vaults, whatever services we need to have. Now in Azure, we have log files are shipped to application insights, which can be outside the security boundary. We have Key Vault for a bunch of our secrets, where the services identity, the system managed system identity of the service of the application has access to the key vault it needs. We have app config outside the security boundary. App config does not contain any secrets. It contains pointers to the key vault. And here's a thing about key vaults. Never share key vaults between environments. You should never have the same key vault for your developer or test environment as your production environment, because you can't add access, you can't grant access to single secrets. You can only grant access to a bunch, to all the secrets. And depending on your configuration, you would consider having a separate key vault for separate apps. So this app has this key vault, this app has this key vault, or maybe these apps have that key vault, depending on the level of confidentiality between your apps you need. Now, within a security boundary, we should not have common access. We have, of course, data lying around here where we don't have access directly to data. We have super users who have access if we need it. But the roles here have access here. Now, what you can also do, if you have services that do not support privileged identity management, maybe you have some legacy services, maybe you have some other kinds of services, it is not super hard to make a service running one identity which has permissions to alter permissions. So you can have, and you can log on here and you can do the same things that privileged identity management has out of the box, but you can do it for your services that do not support them. And you can say, well, I would like to have this permission and granted access for 1 hour. And then this identity here, which is this service, can go and make that change, grant you access, and then have a job that cleans up access after so-and-so log. It's not a really hard system to make. It can be used for those cases where you're not able to use privileged identity management. For instance, if you want to add your user permissions in a SQL database. And then we have admin systems that will read data and show only the data that we actually have a use for. No. So the problems here are often that we want to get this access right away. It feels inconvenient, and this is largely a mindset thing. It doesn't take long to go in and just use privileged identity management and set it up, and it's a learning curve with it. I'll admit that it's a lot of things, and it's not just for Azure; it's for the entire system of Office 365 and Azure. So it can be reasonably overwhelming. But if you spend a day or two with it and figure it out, it becomes pretty reasonable to set up. You want to set sound policies on it so that you can. It's easy for people to get the access they need when they need it. If you want to have approvals, that's one thing. If you don't have approvals, that's also fine, depending on your threat model and your security reasoning. So that's my suggestions. On your next actions is to make sure you have a super user. Again, make sure you can, that is your final emergency escape hatch. If nothing else can be done, if I can't do it with the tools I've set up, I can always go to that and log in as that user. And you should have some kind of form of auditing on that. You can ship your logs to Azure Monitor, for instance. You can audit an alert on that. Use a CD system, a continuous deployment system. You can include approvals here, like I mentioned, that it doesn't have to be automatic deployment. It can just deploy this now, deploy this version now. But make sure that your code goes into production untouched by human hands. But do set up a review process so that nothing gets in without having at least 2 pairs of eyes on it. Get rid of passwords. Passwords are no, identities are yes. Getting identities instead of passwords very much lowers the risk of having unauthorized access to resources, because then you have passwords that are floating about and nobody knows who has what and what version. Use stuff like Key Vault to keep your passwords and secrets safe, the ones you need. Make sure you have access to log files, but watch for personal identifiable information, especially, and sometimes also, depending on the system, business or trade secrets, which you don't want. Look into PMI. It is a relatively simple tool once you just get the hang of it, and it will dramatically increase the security of your system and the auditability of your production access. Right, that's what I had for today. If anyone says, why isn't the app config service also within a secure boundary? There's a question. Good question. It's easier. It's nothing particularly secret about it. We don't have any PMI, should be PIM. Privileged Identity Management. Yes, that is true. Privileged Identity Management. There you go. Thank you. App config, for us, app config is not particularly secret. And also, app config has, I lost my way. There we go. App config has a nice feature where it can have secret or config settings with the same name, but different environments, which makes it pretty easy to handle config settings across environments. In our model, the config settings are not useful for on a secret level. You can't do anything really malicious by changing those. The worst you can do is create a break in the system, but it's not particularly likely. Depending on your data, then you might want to put app config in the production environment. Your mileage may vary. Another question is, minimizing access right in production necessary for GDPR compliance or just good practice? Yes, or let's say maybe and yes. GDPR has some fluid wordings or unspecified wordings that you should minimize access to production. What that means is context dependent. It might mean something for one company and something for another company. What I've seen is that people are generally very positively inclined when you say that we don't have access to production environment. Oh, that's nice. And it will certainly help you with a GDPR related case. It is not necessarily to have no access, but there is parts of the GDPR that says you should minimize access. So, but what does minimize mean? Where if you're 4 developers, is having 4 people access to production environment, have you minimized access? If one has it, have you minimized it? If 0 has it, then you really minimized it. But it also has wordings that would imply that you have to have auditable access. So you might want to. I am not a lawyer, although I work in a law firm, so I'm not going to give you legal advice on that. But I think it's good practice, and it certainly helps with GDPR compliance. Any other questions? I'll hang around in the Slack, so you can message me there if you want. You can also find me on Twitter, Henriksen. If that's, I'm just going to say thank you for showing up, and I hope you have enjoyed the last leg of the NDC. And since there was no party yesterday, you're all fine and set for a whole day of talks. So thank you.
All right. Thank you, Glenn. Very informative.
Thank you, Dennis, for nice words. Have a good day, people.
Drinks, by the way, Glenn, and I had 2 bottles of wine, so I'm not feeling great.
There you go. Well, that's on you, isn't it?
That was on me, so it's my fault. But thank you for a great talk, and I love the way it was presented. So
Thank you, Liam. Thank you. I was kind of curious how that format would work out, so I'm glad you liked it. I was hoping to make it a. I know online conferences and webinars can often get a bit dull with slide after slide after slide, so I was hoping this would mix it up a bit.
Yeah. Thank you very much. Have a great rest of the conference.
You too, Liam. Have fun.
Thanks.
Can people unmute themselves, or are they forced to unmute?
Yeah, they can unmute themselves.
So if anyone wants to ask a question, then go right ahead and unmute yourself. But who's on after me in room 8? Does anyone know?
Yes, that is Vishwas Lele with containers and Kubernetes.
Vishwas is good. You should all hang around and listen to him. I don't care what he has to say; it's always good.
Another MVP.
I'm not an MVP.
Oh, aren't you?
Nope. I used to be, and then I did a bunch of other stuff that wasn't MVP-ish, and I was not renewed because I hadn't been active enough in the community. Life happens sometimes.
Yeah.
And I was not reviewed, and I haven't been an MVP. I was in 2016 was the last year I was an MVP.
Yeah.
It's